Welcome back. In the previous video, we walked through the scikit-learn Python library as well as walked through a simulated example of linear regression. In this video, we're going to go through a project called Boston Housing project, where you're going to use the Boston Housing dataset to predict the house price in this area. So a couple of things before we get started. We need to just set up the environment here. As previously, what I've done before is create a folder called Boston Housing Project, and just to help you remember, this is how you actually set up the environment for this project so that it doesn't actually mess up your other projects. I've already done these first few steps here. You can actually refer to the documentation as well. I'm going to go ahead and create the project now. Instead of calling it project name, I'm just going to call it Boston Housing Project. Okay, so run that, and once that is finished, we just need to activate this. Yes, okay, activate the Boston Housing Project. Okay, once that's done, you will be able to see that Boston Housing Project is already running there. So conda install name and then Boston Housing Project. We just need to install Spider just to make sure that we are running the same version as the version that we've installed. I'm going to speed up this part now. Feel free to fast forward to the next portion once this part is finished installing. Okay, so where do we get the data? The first thing that I want to show you is this location here. It's called Machine Learning Databases Housing. So I'm just going to point you to this location. It's actually run by UCI, UCI Machine Learning. So let's just look that up. It's the machine learning data sets provided by, that's not the right one, UCI machine. So this is where it is, machine learning repository provided by UC Irvine. So in any case, if you look into the folder, there is the housing data. This is the actual data itself. Housing.names, this is the description of the data. I've already opened it up here. You can refer to this. So it's the title of this is Boston Housing Data. These are the sources, and the past usage are the relevant information. Really, this concerns housing prices in the suburb of Boston. There are 506 instances or number of rows, and the number of attributes is 13 continuous attributes and 1 binary value attribute. So these are the description for now. We'll come back to that. We'll leave that for now. What I have done, however, is that I have saved the two files into the folder of Boston Housing Project to save you from the hassle of looking that up. So I'll just leave that here and clear the screen. If you look at the directory itself, you will see that the two data, housing.data and as well as the housing.text, above there. The housing.text is really the description of the dataset itself, which we saw earlier. Okay, and the housing data is really the actual dataset itself. So what I will do right now is run a Jupyter Notebook. Remember that we do need to set the directory to nothing so that we can actually run it on the current directory that we are in. Okay. So notice that the two dataset is indeed there. Okay, so let's set up a new Python notebook, and we're just going to call this Boston Housing Price Prediction. The basic things that we need to do is just import the basic library for now, and the rest, as we need them, we will import them. So for the first thing that we want to do is read the CSV, and the CSV file name is the Boston.data, and we save this into a data frame called dfs. So this is well, it didn't import correctly. So what we need to do again is have a quick look at the data itself, just to see what is the how it is actually set up. So let's just use the notepad and have a look at this. Okay, looking at this, these are the actual data itself. So so basically we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So just like the description stated earlier, there should be 13, okay, plus 1, so 14 columns of data. Okay, so what we need to do here is to actually import this, and with the without headers. So what do you do when you actually come across a problem like this, where clearly the data actually shows that it is in column, but you just need to understand the actual characteristics of the raw data itself. It's not comma delimited. Pandas, yes, we read it as comma delimited, so it has problem identifying that. That's the first problem. That's why these are one big block. And the second problem that it encounters is the issue of we don't have any headers. So what we will do is, the first thing is change the delimiter. The white space is true. Okay, so let's just do this step by step. Notice that now it renders individual column correctly. Okay, so the next thing that we want to do is the header itself. It's actually there's no header, and now the data is actually being imported correctly. So having done all of that, just basically wrangling with your data a little bit just to ensure that it is actually in the format that you want to actually work with. The next thing now is to actually look at these individual column and see what they actually really mean. So let's pull out the descriptor that we have earlier and copy these across so that we have a reference. All right, I've copied the description of the individual column from this descriptors here from the original directory. So basically copy this, open this up, and what you have here is the actual breakdown itself. The column 1, which is called crime rate by town. Second one is proportion of residential land zone, and on it goes. So these are the descriptors, which is crucial for you to understand how the data set works. And the second thing is that the code helps you to label the columns title itself, because the 0 to 13 is not very descriptive. So what I've done next is save all the column names, the shortcodes, into a list like so. So exactly CRIM, ZN, Indus, CAS, all the way to medium values. Store that in there and relabel the columns and name. And when you print it out, initially what we done, the header don't have a label. Now we actually have a header with the exact label itself. Now having done all of that, so what we now have is the crime rate per capita by town. You can actually see the value here. The next thing is that you can see the proportion of residential land zoned for lots over 25,000 square feet, and the proportion of non-retail business acres per town. Charles River dummy variable, basically 1 equals to 1 if it track Bounds River, or 0 otherwise. NOx is nitric oxides concentration. Next one is average number of rooms per dwelling. Age is proportion of owner-occupied units built prior to 1940. So this has to do with the actual house age itself. So if you look at the age itself, 65, 40, 65%, 78%. DIS is distance, weighted distance to 5 Boston employment centers. RAD here is the index of accessibility to radar highways. Tax, fully value, property tax rate per 10,000. Pupil teacher ratio by town, so PT ratio, the higher obviously the better. At least that's our intuition, so later on we're going to test that. B is where black people is the proportion of by town, so the proportion of blacks by town. L stats here is the percentage of a lower status of the population, and MEDV is really the median value. Okay, so what have we done here so far? So essentially we basically need to understand how the actual data itself consists of. What data do we have to perform and our analysis and modeling. So this is really the first step of understanding how the actual data is, and from here what can you actually what kind of intuition can you actually develop from looking at the data. So really this is actually the first step, so I'm going to call this first step and just label this. It's called EDA. EDA is really short for exploratory data analysis. Typically in this step, we do perform some visualization and perform some data crunching just to understand how the data is distributed. So Pandas comes with a really useful tool called describe. So the data that data frame is or the variable is df.describe. If you look at this, is the crime rate. There's the first column or first row, I should say, is the number of instances or number of observed data, and looking at the mean, the standard deviation, the smallest number, and the 25th, 50th, and 75th percentile, and the largest number. Looking at this, you can immediately get some pretty quick observation, and you will observe that CHAS, which is Charles River dummy variable, is very small compared to either Indus or ZN. And Knox is also very small, so these two are the small numbers here. CAS is obviously 0 and 1 variable, where it actually did say that if it's binary, is either 0 or 1. The reason I want to highlight the small number of Knox, for example, relative to Indus, means that when you actually perform your regression later on, the Knox is likely to be suppressed by the data in Indus. And quite often we will perform some pre-processing or normalization before we actually conduct our model. Okay, so we'll come back to that. So looking at text, roughly you can actually see all of the so-called data itself. Okay, the next thing that we want to do is perform some visualization, and that will be the last step that we will do in this tutorial. And I'm going to turn it over for you to actually play around with the data after I show you the steps. A couple of things we want to do is import the matplotlib as PLT, and also typically we use Seaborn because it does have a very nice visualization technique. And okay, I won't set that. Okay, and what we will do is just conduct the pair plot. Now this is likely to be a massive chart because it is quite big. So let me see if I set 1.5, what would it look like, because we are trying to plot in essence 14 by 14 pair plot. Alright, as you can see here, it's really rather big. It's probably a little bit difficult to visualize all of these. So you will have cream with cream. Okay, so this is cream with cream, and you can see the distribution is, bulk of it is actually at the lower end and some distribution to the right end. And looking at ZN, it's proportion of residential land zone for lots over 25,000 relative to itself, most of them are quite small with some pretty large plots of land there. A couple of things that's quite interesting to visualize that you can very quickly get some intuition is this doesn't look like a linear. Obviously this is non-linear. What else can you pick up here from just looking at the chart itself very quickly? There's some non-linear characteristics. There's another non-linear one here. What we might do is that just reduce the actual size itself so that we're not working with such a big data set. Our eyes just, well, let's face it, unable to actually decipher most of this very quickly. So let's just pick some set data for us to visualize. Let me just take this. I'm not going to remember all of that. So I'm going to insert a column here. And this is the specific column that we want to study. Land size, non-retail. We're gonna skip the binary for now. Okay, nitric oxide, number of rooms dwelling. Okay, I think that's pretty much what we want to play with for now. So 4 is sufficient for our purpose. So let me just move this column down to the end, and we repeat this study here, except that instead of looking at everything, so we are going to look at the column that we are going to study. So let's just make this bigger. Okay, that's better. All right, looking at this, okay, so you have probably need to actually refresh your memory. So we look at the, okay, let's just copy this across so that you can directly reference it. Most of it's not going to have such a great memory. Okay, we're looking at Zn, which is proportion of residential on land zone for lots over 25,000. So there's actually a small proportion, and distribution is taper off quickly. And the next thing that we are looking at is the Indus, proportion of non-retail. Okay, so there's the distribution look like this. And looking at all the other plots, there aren't really a lot of characteristics that you can really picked up here. They are all over the place. So there's probably some slightly linear here. The NOx and with Indus, what is that? The nitric oxide seems to actually have well, the greater the number of industry, proportion of land that's actually set for industry or business, non-retail business, the number of nitric oxide seems to actually pick up relatively. RM here is average number of rooms per dwelling, seems to actually decrease relative to the number of business. I guess you can actually, there are some interesting characteristics there, but not really conclusive. So this is really how you actually study that, just to actually get some intuition from your underlying data. So with that, I'm gonna stop and let you to try this out. This is the assignment that I have for you. I would like you to actually play with the pupil-teacher ratio, okay, and also the so-called proportion of blacks by town, and also look at the median value. Okay, so these three things: PT ratio, the B, and also MEDV. Perform a pair plot as I did. See what kind of conclusions can you actually draw out of that, and some intuitions that you can draw out of that. I'm going to pause the video now. I'm going to let you try that out and see what it looks like. So how did that go? Did you manage to try that out, being the pupil-teacher ratio, the black proportion of blacks by town, the percentage of lower status of the population, and finally the median value? I hope you tried that out, and this is what it looks like for me. In the next video, we're going to look at continue to look at the data itself, look at some correlation between the data sets, and also actually implementing a linear regression on our data before we move on from developing the actual full model itself to predict the house price. I look forward to seeing you in the next video.